Hello everyone, this is a walkthrough of my final year project which is titled Analysis of Running Form with Keypoint RCNN. My supervisor is Associate Professor Dr. Ng Wee Kiong. A little bit about the project. This project aims to use Keypoint RCNN, a human pose estimation model, to analyze running form. The ultimate goal is to create a full-stack web application that casual runners can use to improve their running form. So here's the scope of the project. First is to create a post-processing algorithm for the output of Keypoint RCNN. Next is to collect data for the train set and the test set. Next is to calibrate and test the post-processing algorithm to improve it. And lastly is to create a full-stack web application with Keypoint RCNN and the post-processing algorithm in the backend. Before we can analyze running form, we need to look into what constitutes good running form. There are many aspects of running form, but this project focuses on two, and the first one is overstriding. Overstriding occurs when the front leg extends too far in front of the body whenever a step is taken, and it is one of the most common and notorious running problems. This puts the body in a poor position to naturally absorb shock, and it increases the forces acting on the ankle and knee joints. The image in this slide shows a runner that is clearly overstriding. The second aspect of running form that we will be looking at is forward lean. A large value of forward or backward trunk lean is associated with higher energy costs. This suggests that there's an optimal angle of forward lean, not too far forwards or backwards. For example, the runner in this image has a good angle of forward lean. Now that we know what constitutes good running form, I'll give a brief introduction to Keypoint RCNN. PyTorch's Keypoint RCNN is a human pose estimation model that is based on the mask RCNN paper. It was trained on the COCO dataset for humans. It is able to detect 17 key points in the human body, as shown in the image on the left. For the collection of the train set, I collected more than 100 side profile images of Eliud Kipchoge from Kenya. Eliud Kipchoge is a two-time Olympic gold medalist in the men's marathon, the current world record holder for the event, and the only human that has run a marathon in less than 2 hours. Next, I used the train set images to come up with a post-processing algorithm for the output of Keypoint RCNN. There are a few things that the algorithm does. Firstly, it filters out the desired key points. Keypoint RCNN identifies 17 key points, but we only need 7 of them. The algorithm also identifies the main subject of the image. This is important as many of the images are quite noisy in the sense that there are multiple people in the image as seen on the right. Finally, the trunk and knee angles are calculated. After that, I ran the full pipeline on all my images in the train set to calculate Eliud Kipchoge's trunk and knee angles. The results are shown here and they will be used as a basis for comparison. For the purposes of this project, a runner with a ground contact knee angle which is smaller than 83.67 degrees is considered to be overstriding. Similarly, a runner with a trunk angle of less than 62.11 degrees is leaning too far forward, while a runner with a trunk angle of more than 73.09 degrees is running too upright. While Kipchoge's running form might not be completely perfect, he is still a good basis for comparison, as he is an accomplished professional runner with almost impeccable form that casual runners should definitely seek to emulate. Next, I collected the test set, which consists of an additional 50 images to calculate the accuracy of the Keypoint RCNN and post-processing model pipeline. The evaluation metric used in this project is Object Keypoint Similarity or OKS, developed by COCO. This metric gives a value to the closeness of the predicted key point to the ground truth key point. It ranges between 0 and 1, and a perfectly predicted key point will have an OKS score of 1. The equation on the left shows the formula of OKS, but I will not go into too much detail here. The Ki that you see in the denominator is actually a constant that differs for each key point in the body. And the table on the right shows the values of Ki for the 7 different key points that we used in this project. These values of Ki were determined by the COCO researchers. Here are the evaluation results. Each predicted key point was associated with its own OKS score. Each image has 7 OKS scores, and these scores were averaged to give each test image an OKS score. The scores from all 50 test images were collated to give the results in this table. So the Keypoint RCNN and post-processing algorithm pipeline actually achieves a mean score of 0.96, which is fairly close to the perfect score of 1, and only 6 images scored less than 0.9 in the test set. After being satisfied with the performance of the pipeline, I started building the web application. Here's an overview of the software architecture. The front end is built using HTML, CSS, and JavaScript. Images can be uploaded onto the front end, and they are then sent to the Flask server in the back end via REST APIs. The images are then decoded with a package from OpenCV, and the decoded images are sent to PyTorch's Keypoint RCNN for inference. The output from the model is passed through the post-processing algorithm. Thereafter, the results are displayed on the front end in a separate page. Finally, I will give a quick demo of the web application. Here is the web application. At the top of the web application, there's a quick introduction to my project, and there are some instructions for users to help them use it. So to use it, they can simply upload a site profile image of themselves running at a moment when their front foot first strikes the ground, as seen in these example photos. So there's an upload button over here for users to upload an image. So for example, let me just choose an image. So I've uploaded this image, and there's a short wait before I'll be redirected to another page, which is the results page. So based on the results of the calculations done in the back end by the model and the post-processing algorithm pipeline, the trunk and knee angles of the user are compared with that of Eliot Kipchoge's, and based on the comparison, the website will actually give a small explanation as to whether the stride is good and whether the forward lean is good. So for example, in the case of this person, it seems like he's overstriding, which is quite true. As you can see, his front leg is extended too far out of in front of his body, but his lean is good. So from here, the users can actually choose to upload another photo. Yeah, so this is a different photo. And with that, that brings me to the end of the video. Thank you.